In order to solve systems by graphing, what we first do is make sure the equations are isolated, so they're in slope-intercept form. Both of these have the y isolated and they are ready to graph. So then we take one equation at a time. So we'll look at this first one, and it's saying to begin at 2, y-intercept of 2, and rise 1, run 2. So up 1 over 2, up 1 over 2. And I could continue this pattern if I need to, but this is the line for that equation. And if you're really advanced, you would write the equation you just graphed near the line. Okay, so y equals negative x minus 1 now. So I'll do that in a different color just so you can see the difference. So here's negative 1, and I'm supposed to go negative 1 over 1 is my rise over run. So down 1 over 1, down 1 over 1, etc. And I want to see if these lines are going to intersect. They do actually intersect, but I'm having trouble telling where they're going to intersect. So I draw my line. If I'm really good, I'll label my line so I know which one's which. And then if I continue that pattern of down 1 over 1, so go up 1 to the left 1 instead, up 1 to the left 1, we can actually see where these two lines intersect. And the solution, the answer to this problem, is that ordered pair. So where these two intersect is at negative 2 on the x and 1 on the y. And you can actually check your work as well. You can plug that negative 2, 1 back into the equation, into both equations really. So if I do it into the first one, y equals 1/2 x plus 2. And I plug in, my y is 1, and my x is negative 2. And I just calculate, so the 1 is already solved for us. But half of negative 2 is negative 1 plus 2. Negative 1 plus 2 is 1. So since 1 equals 1, this must be the answer, negative 2 comma 1. People like this section because you can check your work and be confident that you have the correct answer. So for this first equation, y is actually isolated. It's written backwards, so some people might want to reorganize that. But the y is isolated. It's by itself. So this first one is y equals negative 2x minus 1. And the next one, y is not isolated. So you can start by blocking off the y, and I'm going to subtract 3 from both sides. So I have negative y equals x minus 3. To get rid of the negative y, you're dividing, it's a negative 1y, so you're dividing everything by negative 1, or you're really just changing the sign of everything. And so y equals negative x, or negative 1x, and negative 3 divided by negative 1 is plus 3. So here's my two equations that I'm about to graph. My first equation, I'm going to begin at negative 1. And I'm going to go down 2 to the right 1. It's negative 2 over 1 for rise and run. So down 2 to the right 1. Down 2 to the right 1. And I could continue that pattern the other way. I can go up 2 to the left 1. Up 2 to the left 1, etc. And again, if I'm really good, I'll write my equation down here so I know that that red line is negative 2x minus 1. Okay, my blue line, I'm going to do y equals negative x plus 3. So I begin at 3, and I'm going down 1 over 1, down 1 over 1. I'm supposed to see where these intersect, so I'm going to go up the other way instead. Up 1, left 1, up 1, left 1. And they're intersecting right at that blue point on the red line, which is at negative 4, comma 7. And again, I can plug that back in. So let me just pick one so that you can see that it works. Negative 2x minus 1 equals y. So negative 2 times x, which is negative 4, minus 1 equals 7. And we'll calculate that. Negative 2 times negative 4 is positive 8 minus 1 equals 7. Well, 8 minus 1 is 7, so 7 equals 7. So negative 4 comma 7 must be correct.